However, the probability of selecting a red or blue marble is found by the addition rule for probability, and that's the probability of selecting a red plus the probability of selecting a blue minus the probability of selecting a red and blue marble. The likelihood of selecting a red marble is 2 over 10. Likelihood of selecting a blue marble is 1 out of 10. And it's impossible to select a marble from a bag that's both red and blue at the same time for this particular bag. So we have 2/10 plus 1/10, and that'll equal 3/10 as a fraction. If we look at what 3/10 is numerically, we'll find the answer is 0.3. If you pick a card from a standard deck, what's the probability of picking a question 1, ace and a spade? Question 2, ace or a spade? Question 3, club and a diamond? Question 4, club or a diamond? Select a card from a standard deck. The probability of selecting a card that is an ace and a spade at the same time is known as the ace of spades. There's one ace of spades out of the 52 cards. If we select a card at random and the question is, what's the probability of selecting an ace or a spade? We use the addition rule. So probability of selecting an ace plus the probability of selecting a spade minus the probability of selecting an ace and a spade at the same time. That's the ace of spades. 4 over 52 plus 13 over 52 minus 1 over 52. The answer becomes 16 over 52. Numerically, this is what we get. If we approximate the answer to the nearest thousandths, the 7 is in the thousandths position. The digit to the right, which is a 6, means we add 1 to the 7, and it's 0.308. If we select a card at random and we ask, what's the probability that the card is a club and a diamond at the same time? Well, that's 0. That's because the event of picking a club and a diamond when you select one card is impossible. There are no cards that are both clubs and diamonds. However, if the question is, what's the probability of selecting a club or a diamond? We simply use the addition rule. The probability of selecting a club plus the probability of selecting a diamond minus the probability of selecting both a club and diamond at the same time. 13 over 52 plus 13 over 52 minus 0. 26 over 52. The answer is 0.5.
mortality. If we pick a passenger at random, what's the probability of picking a passenger that's 1. A man, 2. A survivor, 3. A man and a survivor, and 4. A man or a survivor?
Viewing the Titanic information, the probability to select a passenger at random that it's a man is 1,692 divided by the 2,223 passengers. If you select a passenger, you ask what the probability that the passenger survived. Well, there were 706 passengers that survived out of the 2,223 passengers aboard the Titanic. The probability you select a man who also survived is found by noting that there were 332 men who survived out of the 2,223 passengers. If you select a passenger at random and you ask what's the probability it's a man or a survivor, we use the addition rule. The probability you select a man or a survivor is the probability that you select a man plus the probability you select a survivor minus the probability it's both a man and a survivor. 1,692 men out of the total, 706 out of the total, minus 332 out of the total. $2,066. 2,066 out of the 2,223 passengers were men or survivors. Numerically, we divide that number by the total number of passengers. If we approximate this number to the nearest thousandths, the second 9 is in the thousandths position. The digit to the right is a 3, which means we keep the 9 and do not add 1 to the 9. The answer is 0.929. Back to the Titanic.
The definition of conditional probability. That's the probability of A